Today we are starting overview of ARM Cortex M4. We are starting with general purpose input output. So this is the very basic concept and a fundamental concept to start with. Controller. We start generally with the IO pins, how to configure them, what all interfaces are available, and what all are common practices that are followed while dealing with general purpose input output pins and the clock distribution. So these things we will learn in this today's session. So this is how today's session is distributed. So we'll first introduce the GPIO, what is it, and all different types available. Then interfacing of GPIO pins, followed by the common registers that are used to configure and to use GPIO registers or pins. Then various types of buses and what the difference between those buses. And finally, the clock sources. Okay. So MCU pins are grouped into a port. So they call it as a port, and nomenclature for a particular pin is port uh, followed by which port it is, like port A, followed by pin number PA1. So it stands for port A pin 1. So there are various ports, as we can see in the diagram, port A, port B. So here we see port A pins, then here port B pins, here we see port C pins. So to access any port pin, this is the symbol that we are going to follow. So PA1 means port A pin 1. GPIO interfacing. So there are two types of general purpose or input output pins. First is general purpose input output, which is also called a GPIO, and it follows the general purpose of the pin as either input or output based on the way it is configured. And mostly it is used to read signals from any input devices or output to drive output devices, such as LEDs, which is LED, which is an output device, while switch or push button, which is an input device. So for that purpose, GPIO pins are used. Second case is special purpose input output. In this, the IO pins are they have multiple purposes defined to it, and so we can decide at the time of or we can configure that particular pin as per our usage. So for example, a particular pin could be used as a transmit or TX pin for a UART communication, or a particular pin can be used for RX or receive of UART protocol. So likewise, so this is the simple example of a special purpose IU pin. So it has multiple purposes, and programmer has to decide or configure at the beginning for what purpose that particular general purpose IO pin will be used. Common registers that are used for GPIO, so at least two registers are used, and this is common across almost all controllers, microcontrollers. Uh, so I'm using this word at least two registers, and these two registers are direction register and data register. Now, direction register is used to set the pin either as output or input, while the data register is used to write to a pin or to read from the pin. Okay, so direction register basically sets the direction of that particular pin as either input or output. So, for example, in case of LED, which is an output device, the GPIO pin or the direction for that particular pin will be set as output. Whereas in case of push button or switch, uh, which is an input device, to read the data or the action that is done on the switch or a push button, we have to configure that particular pin as input. So in that case, in the direction register, we have to configure it as an input. Data register, same thing. So if we want to write data on any particular pin or we want to drive the output, then mostly we set that particular pin to 1, and that's how we drive that pin high. Example, LED again, which is an output device. So we write uh, on that pin logic high or 1, which will make the LED on. Basically, it's you can write 1 as well as 0 on that pin based on the output that you expect. Whereas if the input device was connected on that pin, like switch or push button, then to read the status of that pin, uh, so whether the button is pushed or it is not yet pushed. So based on that, it will have some logic level on that particular pin, and the data register will read the data or the level on that particular pin, either high or low, and that will be the data that will be treated as a data in the data register. MCU buses. So there are two types of buses. Uh, Advanced high performance bus, also called as AHB, and advanced peripheral bus, also called as APB. So difference between these two buses is, of course, as the name suggests, advanced high performance. So it is a high performance bus, and it is faster as it takes only one clock cycle to access peripherals. So as compared to advanced peripheral bus, which takes minimum of 2 clock cycles to access peripherals, and which is slower as compared to the advanced high performance bus. So now this is talking in general. Now, when we go into the details while dealing with the peripherals, uh, like interfacing peripherals with the microcontroller, we will deep dive into this particular part, how these buses are basically making basically significant in this case, and how we can define or decide which bus to use for what application. Next, MCU clock sources. So there are multiple clock sources that an MCU can have. One is on-chip RC oscillator. So here RC means resistor and capacitor, which is like conventional way. Second is externally connected crystal. So the crystal basically can connect it externally, and that can act as a clock source. And finally, the phase lock loop. This phase lock loop basically again it's a programmable clock, and we can generate multiple clock signals of various frequencies through phase lock loop, which is programmable. So among these, the least precise is on-chip RC oscillator, whereas externally connected crystal oscillator is the most precise one. And phase lock loop, as we discussed, it's a programmable, so programmer can decide uh, based on the requirement. He can generate the clock signals as per his need. Okay, so let's revise quickly. So we discussed on the GPIO part, mm, the introduction. There are two types of GPIOs, general purpose and special purpose IO pins. Then interfacing, uh, then we learned about common registers that are direction and data register that are used in almost all microcontrollers. Then we learned about two buses, the high performance bus and the peripheral bus. Then and the difference between two, the which one is faster and slower, and various clock sources that MCU can have, and uh, the precision levels of those clock levels, clock sources we discuss. Okay, so thank you. So we will move on to the next part, which is the programming part.